A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
Astronomers tracking 3I Atlas say it has altered its course, worrying scientists about its close proximity to Earth.
The announcement from Harvard researchers and NASA specialists that the interstellar object 3I Atlas is on a trajectory toward Mars has ignited waves of both astonishment and apprehension across scientific circles and the wider public. This discovery, emerging from a synthesis of telescope data, orbital modeling, and predictive simulations, marks one of the rarest cosmic revelations in modern times. Interstellar objects are already exceedingly uncommon visitors drifting into our solar system from the depths of space, but the idea that one could collide directly with a planet like Mars elevates this phenomenon into unprecedented territory. It is not merely an astronomical curiosity, but a moment that forces humanity to reconsider planetary defense, cosmic dynamics, and our place within an environment that is ultimately governed by forces far beyond our control. Before we start, hit the like and subscribe buttons for more exclusive news. The designation 3I Atlas itself carries significance. The I denotes that it is interstellar, joining a lineage that includes only two prior recognized objects of its kind, the cigar-shaped Oumuamua and the comet-like 2I/Borisov. The identification of a third interstellar traveler already expands the canvas of cosmic research. However, unlike its predecessors, which swung past the sun and sped outward into the galactic dark, 3I Atlas has shown an orbital path that intersects directly with Mars. The mechanics of this trajectory were calculated with a precision that allowed scientists to determine its likely point of contact. The convergence of Harvard's theoretical modeling with NASA's observational data lent the claim an authority difficult to dismiss. Suddenly, what once might have been relegated to speculative scenarios has emerged as an imminent reality, giving urgency to the event. The timing of this discovery is also remarkable. Mars has long been at the center of human ambition for exploration, colonization, and resource utilization. Space agencies and private companies alike have poured billions into preparing for a future where humans walk the dusty plains of the Red Planet. The prospect of a natural interstellar impact, with all its consequences, introduces an unpredictable factor into these plans. If 3I Atlas collides as projected, Mars will bear the scar of the event in a way that could influence everything from its atmosphere to its surface environment. Depending on the size, speed, and composition of the object, the collision could unleash an energy release rivaling the most powerful events observed within our solar system in centuries. This is not merely a distant planetary occurrence, but a transformational moment that would affect the trajectory of Martian exploration itself. The composition of 3I Atlas has been a subject of intense scrutiny. Early spectroscopic studies suggest that it carries a mixture of volatile ices and rocky material, not unlike long-period comets that originate from the far reaches of the Oort cloud. Yet because it is interstellar, its chemistry may also hold exotic elements or isotopic ratios not commonly found in our solar system. This possibility excites planetary scientists and astrobiologists alike, as the impact would deliver alien matter directly into the Martian environment. Unlike meteorites that have occasionally fallen to Earth, this event would provide a massive infusion of interstellar material into another world, creating a natural experiment of cosmic contamination and exchange. Researchers see in this moment the potential for unlocking clues about stellar formation, galactic chemistry, and even the likelihood of life's ingredients existing beyond our solar neighborhood. The sheer scale of the anticipated collision has drawn comparisons to historical impacts that have reshaped planetary histories. Earth's own narrative includes the cataclysmic Chicxulub impact, which coincided with the end of the dinosaurs 66 million years ago. While 3I Atlas is not necessarily of the same magnitude, its interstellar origin adds an extra dimension of mystery and unpredictability. The speed at which it travels is higher than typical solar system comets due to its foreign trajectory, meaning the energy released on impact could be significantly amplified. Mars, with its thinner atmosphere, would provide little resistance. The planet's geological features, ancient craters, dried riverbeds, vast plains, could soon include a brand new scar carved by a messenger from beyond the sun's gravitational reach. Harvard's involvement in the analysis underscores the academic weight of the findings. The university's astrophysics department has long been at the forefront of theorizing about interstellar phenomena, and in this case, its researchers applied advanced dynamical models to predict the collision's certainty. Their predictions, when cross-referenced with NASA's space-based telescopes and orbital trackers, created a rare alignment of theory and observation. Both institutions, often cautious in their public statements, agreed that the probability of impact was high enough to warrant serious attention. Such consensus is not reached lightly, making this announcement one of the most credible and consequential in planetary science. The announcement reverberated beyond the scientific community. Policymakers, aerospace companies, and the public at large quickly latched onto the implications. For governments investing heavily in Mars missions, the news represents both a potential setback and an opportunity. On one hand, the delicate plans for robotic rovers, orbiters, and eventual human missions may face disruption if the planet's environment changes drastically. On the other hand, the collision could create new scientific opportunities, turning Mars into an unparalleled natural laboratory. There is little doubt that space agencies are already recalibrating their objectives in light of this looming event, considering how best to position instruments, satellites, and surface assets to capture data. For the public, the idea that Harvard and NASA have warned of a planetary collision resonates with both awe and anxiety. Humans have grown accustomed to imagining Mars as a future home, a place of both adventure and refuge. The notion that this very world is about to undergo a violent transformation disrupts these narratives. Yet it also deepens the sense of Mars as a dynamic, living planet subject to cosmic forces. Just as Earth has endured its share of impacts and upheavals, Mars now finds itself the stage for an interstellar encounter that will be watched closely from billions of kilometers away. The psychological impact of witnessing such an event, lived through telescopes and space probes, will be profound, reshaping the way humanity relates not only to Mars, but to the cosmos itself. Astrophysicists emphasize that the collision, though potentially destructive, is also a rare scientific gift. Interstellar material is incredibly difficult to study, as objects like Oumuamua and Borisov passed by too quickly for in-depth exploration. A direct impact provides an entirely new way of examining this kind of matter. Mars orbiters and landers could capture data on the ejecta, analyzing the dust, gases, and debris flung into the Martian sky. This would give scientists a unique opportunity to probe the chemistry of another stellar system without leaving our own. The implications for understanding the distribution of organic molecules, metals, and volatile compounds across the galaxy are immense. In this sense, Mars becomes a cosmic intermediary, hosting an experiment that no laboratory could ever replicate. The dynamics of the impact also raise questions about planetary defense and interstellar monitoring. Earth has long considered the threat of asteroids and comets from within the solar system. But 3I Atlas reminds humanity that cosmic dangers also drift in from the wider galaxy. Though Mars is the immediate recipient of this collision, Earth's proximity underscores how interstellar objects cannot be ignored. This event may spur greater investment in telescopes, early detection systems, and theoretical work designed to identify such travelers long before they approach inner planets. In the broader narrative of planetary defense, 3I Atlas is a wake-up call, demonstrating that the solar system is not an isolated bubble, but an open arena subject to galactic interactions. The cultural and philosophical dimensions of the event cannot be overlooked. Humanity has always gazed at Mars with curiosity, mythologizing it as a war god, a red jewel, and a potential twin to Earth. The impending strike by 3I Atlas reframes that mythology in dramatic fashion. It reminds us that worlds, no matter how storied, are not static backdrops but active participants in cosmic drama. To witness Mars absorb the force of an interstellar object is to confront the reality of impermanence, the idea that no celestial body is immune to change. For some, this reinforces a sense of humility before the universe. For others, it ignites a desire to harness these events for knowledge, to transform destructive energy into insight. At the same time, the impending impact has galvanized discussions about humanity's future on Mars. If colonization is to be pursued, events like 3I Atlas must be factored into long-term survival strategies. How will structures, habitats, and technologies be designed to withstand not only environmental extremes but also cosmic collisions? While Earth offers a relatively protective atmosphere and magnetic field, Mars is more exposed. The looming impact underscores that any future settlers would live in a precarious environment shaped by both internal and external forces. The event therefore highlights the need for planetary engineering, shielding technologies, and adaptive strategies if Mars is to serve as a true second home. The broader implications ripple outward to questions of cosmic interconnectedness. An interstellar object striking a planet within our solar system creates a bridge between galactic regions, a literal exchange of matter across the stars. This is not a metaphor, but a physical reality. Dust, molecules, and atoms that formed around a distant star will soon merge with the Martian crust and atmosphere. This blending of materials could inform theories about panspermia, the idea that life's ingredients travel between worlds on celestial bodies. If interstellar collisions are not exceedingly rare, then perhaps life itself owes part of its distribution to such exchanges. The Mars event will not answer this definitively, but it will add evidence to a question that has fascinated humanity for centuries. In the lead-up to the collision, preparations are already being discussed. NASA and other space agencies are considering how best to leverage existing satellites around Mars, including orbiters that could act as real-time observers. Landers and rovers may be repositioned or recalibrated to record the aftermath of the impact. Instruments designed to study Martian geology may soon find themselves recording data from freshly deposited interstellar material. Harvard's theoretical teams continue to refine impact models, predicting crater size, ejecta patterns, and possible atmospheric disturbances. The collision, while dangerous in one sense, is also being reframed as an unparalleled research opportunity. The event is not occurring in isolation. It comes at a moment when humanity is entering a new age of space exploration, with multiple countries and private enterprises aiming for Mars. The presence of 3I Atlas intensifies the urgency of this endeavor, as scientists and engineers recognize that cosmic events do not wait for human schedules. The sense of a deadline imposed by the cosmos itself adds gravity to ongoing discussions about exploration. Mars is no longer just a goal. It is a planet about to undergo a transformation, and humanity must decide how to observe, interpret, and adapt to that change. The anticipation is palpable. As telescopes lock onto 3I Atlas and spacecraft prepare to record its encounter with Mars, the world watches. This is more than a scientific event, it is a collective human moment. For the first time in history, people across Earth may witness, almost in real time, the collision of an interstellar traveler with a neighboring planet. The drama of that spectacle will etch itself into memory, much like lunar landings or deep space images from distant probes. It is not just a reminder of cosmic vulnerability, but also of the incredible capacity for human observation, prediction, and reflection. The impending collision of 3I Atlas with Mars, as warned by Harvard and NASA, has become a pivotal subject not only for astronomers but also for thinkers across multiple disciplines. The rare convergence of a cosmic event involving an interstellar object and the close scrutiny of two of the most reputable scientific institutions elevates the entire matter beyond the realm of typical astronomical news. It is not just about an object colliding with a planet, it is about what that act signifies for humanity's knowledge, ambitions, and future in space. To expand on what this moment represents, one must move deeper into the perspectives of science, philosophy, culture, and even the long arc of human aspirations beyond Earth. One of the most striking aspects of the 3I Atlas approach is the window it opens into planetary dynamics. Mars has long stood as a silent archive of cosmic history, its surface scattered with craters that reveal the scars of an ancient bombardment era billions of years ago. Most of those impacts occurred when the solar system was young and turbulent, a time when rocky debris swirled in abundance. In the present epoch, the frequency of such large-scale collisions has drastically declined, making the impending strike an outlier of monumental significance. Scientists often study craters to reconstruct the story of planetary evolution, but here, they will witness one forming in real time. To observe the event with instruments orbiting Mars is akin to peering into the earliest chapters of planetary formation, but with the added twist that the impacting body carries the alien signature of a distant star system. From a physics perspective, the energy exchange that will occur is staggering. 3I Atlas, traveling at interstellar velocities, embodies kinetic forces far exceeding those of typical solar system comets. The velocity translates into an energy yield that magnifies the destructive and transformative potential of the impact. This is not only about creating a crater, but about triggering shock waves through the Martian crust, vaporizing material, and hurling ejecta miles into the atmosphere. Such a phenomenon will briefly transform Mars into a glowing spectacle, a planet lit by a fireball of galactic origin. Scientists will attempt to model these processes, but the uniqueness of the object's trajectory and composition ensures that no simulation can fully predict what will unfold. This unpredictability lies at the core of the event's allure. In cultural terms, the idea of an interstellar object colliding with Mars taps into one of humanity's deepest fascinations: the intersection of the familiar and the alien. Mars is a world we have imagined in literature, myth, and cinema for centuries. It has been portrayed as a cradle of alien life, a hostile wasteland, or a frontier for human survival. The collision brings a new narrative to that mythos: Mars as a meeting ground between our solar system and the wider galaxy. This idea, that matter from beyond the sun's influence can imprint itself directly upon a planet so close to our hearts and hopes, resonates at a symbolic level. It evokes images of cosmic bridges, where the boundaries between star systems blur and matter becomes a universal traveler. The psychological dimension of the announcement cannot be understated. Humanity has grown used to imagining itself as somewhat insulated from galactic randomness, concerned primarily with the predictable orbits of planets, moons, and asteroids within the solar system. The appearance of interstellar objects like Oumuamua and Borisov cracked that illusion by showing us that the void between stars is not empty, but those bodies were passers-by, quickly vanishing back into darkness. 3. Atlas, by contrast, refuses to remain aloof. It intrudes with the insistence of impact, forcing even the most casual observer of the cosmos to confront the reality that interstellar phenomena are not abstractions. They can and will interact with our neighborhood in visceral ways. The awareness of this truth introduces both wonder and unease, reshaping the collective imagination of space. From the vantage point of planetary geology, the impact promises to alter Mars in ways that extend beyond the immediate explosion. A new crater will not only mark the surface, but will also reveal subsurface layers otherwise hidden to our instruments. The excavation caused by the collision may expose materials that date back billions of years, preserved beneath the crust. For geologists and planetary scientists, this is like opening a vault of history. Combined with the interstellar debris delivered by 3I Atlas itself, the site of impact will be a crossroads of two narratives: the ancient history of Mars and the alien chemistry of another system. The layers of meaning in that intersection make the collision site an invaluable future target for exploration, both robotic and one day human. For astrobiologists, the event carries even more tantalizing implications. If interstellar objects carry organic molecules or prebiotic chemistry, then the mixing of such materials with Martian soil may offer a glimpse into the universality of life's ingredients. Even if no life exists on Mars today, the collision could show whether building blocks of biology are common across the galaxy. This would not provide direct proof of extraterrestrial life, but it would significantly strengthen the argument that life's origins are not confined to Earth's unique circumstances. The philosophical weight of such a discovery would ripple through science and society alike, reshaping how humanity perceives itself in the cosmic story. The warning from Harvard and NASA also sparks reflection on humanity's readiness for the unpredictable. We have designed telescopes and observatories to track asteroids within the solar system, but interstellar visitors pose a far more complex challenge. Their high speeds and unusual trajectories make detection difficult until they are already upon us. 3I Atlas is a reminder that the solar system is not an isolated stage, but part of a galactic network in which chance encounters can escalate into monumental events. The recognition of this truth could inspire advancements in detection technology, pushing humanity to develop systems capable of monitoring not only near-Earth objects, but also interstellar interlopers. At a societal level, the collision presents an opportunity for global unity in observation. Unlike territorial disputes over resources or competition in space exploration, this event belongs to no single nation. It is a cosmic drama unfolding beyond the reach of ownership, visible to all who look toward the red planet. Telescopes across continents, from professional observatories to backyard equipment, will turn their gaze toward Mars. For a brief time, the planet will serve as a common screen upon which the universe projects its unpredictable play. The shared experience of watching an interstellar object meet a familiar world has the potential to bind humanity together in awe, transcending borders and divisions. On the technological frontier, the collision could also accelerate discussions about how humanity prepares for planetary defense in environments beyond Earth. While much focus has been placed on protecting Earth from near-Earth asteroids, the Mars event illustrates that any future human settlement must account for the same dangers. A colony on Mars would not have the luxury of ignoring such risks. The thin atmosphere, lack of magnetic shielding, and geological vulnerability make the planet more susceptible to catastrophic impacts. Thus, the looming event may serve as an impetus to design defensive strategies not only for Earth but for Mars as well, shaping the blueprint for interplanetary civilization. In broader philosophical terms, the warning about 3Y Atlas reveals the fragility of human planning. Generations of thinkers have envisioned Mars as a blank canvas upon which humanity might write its future. Yet the universe itself reminds us that no canvas is truly blank. Every world is already inscribed with histories, forces, and destinies that intersect with our ambitions. To plan for Mars is to engage with a planet that has its own trajectory, one shaped by cosmic influences indifferent to human timetables. The collision will illustrate this vividly, reminding us that exploration must always proceed with humility before forces that dwarf our control. At the same time, the impending strike exemplifies the resilience of curiosity. Despite the potential devastation, scientists and explorers are not retreating in fear. Instead, they are preparing instruments, refining models, and readying themselves to harvest as much knowledge as possible from the event. This reflects a defining human trait, the ability to turn even destruction into insight, to transform what could be seen as chaos into an opportunity for learning. The impact may scar Mars, but it will also illuminate truths about matter, energy, and interstellar origins that would otherwise remain forever hidden. The educational resonance of this event is vast. Around the world, classrooms will seize upon the narrative of 3I Atlas as a living example of cosmic processes. Teachers will be able to point not only to historical impacts, but to a contemporary one, unfolding in real time, visible with the aid of modern technology. For young minds, this will be a formative moment, connecting abstract lessons about space with an immediate and dramatic reality. The collision will become part of the collective memory of a generation, much like solar eclipses or comet appearances have in the past, but on a grander and rarer scale. Artistic imagination, too, will find fuel in the event. Writers, painters, and filmmakers have always drawn inspiration from the cosmos, and the notion of an interstellar traveler colliding with Mars offers fertile ground for creative expression. The spectacle of impact, the symbolism of alien matter meeting a neighboring planet, the psychological resonance of watching it unfold, all these themes will ripple through art and culture. In this sense, the collision is not only a scientific phenomenon, but a cultural milestone, one that will echo through creativity long after the dust has settled. Economically, the event may have implications for how space is valued. The infusion of interstellar material into Mars raises the question of whether future missions might seek to extract and study such debris. If the collision deposits rare isotopes or materials, the impact site could become a high-priority destination. For private companies already envisioning resource extraction on Mars, this adds a new layer of intrigue. While the primary value remains scientific, the possibility of harvesting unique cosmic matter cannot be ignored. The event may thus influence how stakeholders think about the economics of exploration, blending science with commerce in new ways. In the realm of human psychology, the anticipation of such a collision reveals the paradox of fascination with destruction. People are drawn to the spectacle of forces greater than themselves, even when those forces embody danger. Just as volcanic eruptions or solar storms captivate despite their risks, the strike of 3Y Atlas embodies a confrontation with nature's raw power. To watch it unfold will be to stand on the edge of comprehension, witnessing an event that transcends ordinary human experience. The dual emotions of fear and wonder will intermingle, shaping how individuals and societies process the event. Even in theology and philosophy, the collision may find resonance. For some, the idea that a distant traveler strikes Mars could be interpreted as a reminder of cosmic impermanence or divine unpredictability. Philosophers may view it as a metaphor for the intrusion of the unknown into the familiar, a reminder that stability is always an illusion in a universe defined by flux. The event lends itself to reflection on mortality, change, and the broader currents of existence. Mars, so often a projection screen for human hopes and fears, once again becomes a mirror reflecting our own uncertainties. In scientific collaboration, the collision could serve as a model for how humanity handles rare cosmic phenomena. Coordination between Harvard, NASA, and international observatories demonstrates the necessity of pooling expertise across borders and institutions. The event cannot be monopolized. It demands global participation. This spirit of collaboration, if carried forward, may shape how future interstellar phenomena are approached, creating a framework for united scientific response to cosmic challenges. The arrival of 3I Atlas at Mars is more than a celestial spectacle. It is a catalyst that is quietly pushing forward subtle shifts in how science, culture, and technology evolve together. One of the more understated but profound aspects of this event lies in the way it forces human thought to stretch beyond established patterns. Up until now, much of planetary research has been framed around predictable cycles: orbital mechanics, seasonal changes, volcanic processes, and erosion over eons. The collision introduces something disruptive, a single act that alters those cycles in an instant. This kind of disruption is rare in science because most processes studied in astronomy span millions of years. But here the timescale is suddenly human, measurable in months or years rather than geological ages. That compression of cosmic drama into a timeline we can observe adds urgency and intensity, making it not only a scientific investigation, but also a lived human experience. Another remarkable element of the impact is how it could redefine observational astronomy itself. Telescopes on Earth and in orbit are usually focused on distant galaxies, exoplanets, or faint traces of cosmic background radiation. With 3I Atlas, those same instruments will be redirected to watch a violent, fast-moving process on a neighboring world. The redirection of resources demonstrates flexibility in scientific infrastructure, but it also highlights the potential for synergy between instruments that are usually siloed into different specialties. Telescopes designed for exoplanet detection, infrared observatories meant to study dust clouds, and high-resolution Mars orbiters will all become part of a single collaborative effort. The methodologies that emerge from this coordination may permanently reshape how future astronomical campaigns are organized, blurring the boundaries between planetary science and astrophysics. The event also emphasizes the role of chance in cosmic history. While science is built on the search for patterns and predictable laws, the truth remains that randomness plays a decisive part in shaping worlds. Earth itself might not host life had impacts not delivered essential elements or altered climates in key moments. Mars may now undergo another chapter of random alteration, a reminder that the universe is not designed with intention, but with probabilities and coincidences that produce unanticipated outcomes. Grappling with this randomness can be unsettling, but it is also liberating, encouraging humanity to embrace flexibility in its outlook and to understand that not all variables can be controlled or anticipated. In terms of education and public engagement, the collision presents a rare opportunity for planetary science to step fully into the public imagination in a way that abstract theories often cannot. The narrative of an alien body crashing into a familiar world captures attention with a clarity that data charts rarely achieve. Outreach programs, museums, and digital platforms will use this moment to cultivate new generations of scientists and explorers. Children who grow up watching footage of 3I Atlas striking Mars may see themselves as future researchers inspired by that formative experience. This is how single events, even destructive ones, ripple into legacies that shape scientific careers decades into the future. The collision also touches on themes of interconnectivity that extend beyond science and into human identity. For centuries, humanity has defined itself by boundaries, between nations, between Earth and the heavens, between the known and the unknown. But 3i Atlas ignores all boundaries, traveling light years across interstellar space to meet a planet next door to Earth. In doing so, it collapses the distance between the local and the universal, reminding us that we live not just in a solar system, but in a galaxy whose events reach into our neighborhood. This awareness subtly shifts identity from planetary to galactic, encouraging a sense of belonging not only to Earth but to the cosmos as a whole. The very act of waiting for the collision reveals something about human resilience in the face of inevitability. Unlike other challenges that might be mitigated or prevented, this event cannot be stopped. Humanity's role is to watch, to record, and to interpret. Yet there is power in that position. By observing, by transforming inevitability into knowledge, humans turn vulnerability into strength. This is the essence of the scientific spirit, to face what cannot be altered and still find meaning, still build understanding, still expand the horizon of possibility. When 3i Atlas meets Mars, the explosion will be a physical act of destruction, but in its wake it will leave something indestructible: the human capacity to learn, adapt, and imagine beyond the limits imposed by the stars themselves. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3i Atlas possibly hitting Mars very soon? We want to hear from you. Thank you for watching and see you next time.